Hello everyone, I'm Hongxi Chen from the Hong Kong University of Science and Technology, Guangzhou. I'm honored to present our work today, XR Intergenerational Exergame, exploring the complementary roles of VR, MR, and environmental context. In many modern families, children and grandparents live together. However, as digital technology increasingly integrates into our daily lives, the younger generation is more attracted to screen-based entertainment, while older adults often struggle to participate. This situation presents growing challenge for intergenerational families to find common activities, especially exercise, due to generational differences in mobility, familiarity with technology, and theme preferences. Recent research has explored how exergame can foster intergenerational play, encouraging physical, psychological, and enhancing social interactions across age groups. The benefits of exergame are obvious, as they use embodied movement as the core input, which can lower the entry barrier for older adults. However, most exergame are screen-based, limiting play to private environments. Moreover, XR exergame inherit the advantages of natural physical movement and expand the boundaries of game playground to offer more diverse possibilities. Previous studies have explored VR/MR in collaborative play and outlining the unique quality of each. For VR is often valued for its immersion, enhancing motivation and engagement, while MR builds on a shared visible world can facilitate smoother communication with natural social cues like gaze and gesture. Moreover, study about environmental context also indicates that VR exercise in private room can help participants to feel more relaxed and focused, while MR in public space can improve emotional connections and cooperation. Although prior study provides valuable insights across the field, but there is no integrated studies to compare their joint effects. For intergenerational exergame, where players' ability and needs can differ widely, the question is less about choosing one mode over the other. The key is about understanding how each display mode and environmental context can cater to different players' needs. Therefore, we are investigating how environmental context, private space versus public space, and display mode, VR versus MR, affect user experience and collaborative performance. Our contribution includes the following three aspects. In a game we design, two intergenerational players collaborate to maximize their team score within a 3-minute session. The game features asymmetric-role, so children will play as striker, using a virtual racket to hit the color blocks to earn points for the team. Hitting yellow blocks can earn 10 points, while hitting the green block can provide 5 energy points. Meanwhile, older adults play as strategists will perform slow upper body motion inspired by Baduanjing, a traditional Chinese fitness practice. During the gameplay, strategists will monitor the striker's performance and the team score to choose between two power-up categories. Either raise right arms to gain offensive item or raise left arm to trigger defensive item. For user study, we conduct a 2x2 within subject study. Four tested condition includes A. Private space with MR, B. Private space with VR, C. Public space with MR, and D. Public space with VR. In total, we recruit 20 intergenerational peers. The experiment started with a pre-survey and consent form, then tutorial and training section. For each experimental condition, participants will put on the HMD headsets and play for 3 minutes. After each condition, player will complete the questionnaire. The final section is a semi-constructed interview. In terms of key measures, we collect the followings. So for player performance, building on prior exergame research, movement-related metrics are effective tools to assess attention allocation and task engagement during gameplay. Therefore, we collected the team total score to reflect the overall collaborative success. And for children, we track the total hit cubes, hit event counts, and so on, to evaluate the overall active participations and movement frequency. For older adults, we collect total arm raise count, arm raise timestamp, and so on, for the same reason. In addition, for subjective experience, we use short-form versions of questionnaires, including FABQ, IPQ, NMSP, and PENS. The post-section interview includes 5 open-ended questions to gather players' feedbacks on displays preferences, distractions, safety, collaboration strategies, and long-term willingness to play. Now let's move on to the results. Notably, there were no significant main effect or interactions were observed for player performance, so I will mainly focus on the user experience part. For children players, VR gave them a strong sense of spatial presence and involvement. Although they also report a higher safety concern in VR, this didn't stop them from enjoying the immersion. 12 out of 20 children prefer VR, and many stated in the interview because it felt more like a game and helped them focus on tasks. Regarding environmental context, private space can lead to a higher spatial presence and involvement. In MR, children reported a higher co-presence in public space. However, some found it bystander and noise distracting, with 2 children reducing their movement due to feeling awkward being watched by strangers. But one children also found that the unpredictable distraction is very exciting to her. Also, children show higher behavior interdependence in VR. On the other side, for older adults, the pattern is different. In MR, they express significantly lower safety concern and higher comprehensions and co-presence. Interviews confirmed that 16 out of 20 favor MR because it allowed them to see the children's positions and facial expressions, which made them feel safer and more connected. Regarding to environmental context, MR plus private space increase older adults' behavioral interdependence and emotional contagion. Interestingly, in public space, behavioral interdependence was higher in VR than MR. This results suggest that ambient noise and bystander interference might have mitigated some of the safety and co-present benefits of MR in public setting. Our observations showed that older adults often took responsibility for safety monitoring. For instance, when children move too close to the walls, they immediately pause their actions and issue verbal alerts. There are also 2 additional findings. Older adults report higher relatedness in MR, higher competence when playing MR plus public space, and higher competence in private space plus MR. This indicates that MR constantly support older adults' sense of competence, maybe for different reasons. In private space, MR offers safety. In public space, visibility of the real world and their partners enhance their sense of control. In summaries, our results shows the unique generational needs. Therefore, we translate these patterns into design guidelines for intergenerational XR exergame. When designing for children, we recommend leveraging VR immersion to encourage playfulness and maintain task attention. Meanwhile, it is important to create larger safety boundaries, concise HUD, and clear audio feedback. Moreover, game design can also include free exploration mode to encourage novelty. On the other hand, older adults benefit more from MR's visibility. Therefore, we suggest making MR the default display mode for older adults. Designers can also provide simple toggles for players to switch between VR and MR mode. In addition, lower the entry barriers for older adults is important. Introducing the exergame with stationary, low-amplitude movement for safe onboarding, then offer graduate difficulty options to accommodating various skills level. Finally, our study has several limitations. First, we didn't control or measure the bystander density or noise level, which could vary during the gameplay. Second, our older adults participants were relatively active and tech-comfortable individuals. Lastly, our study was limited to a single XR exergame. Future research could address this limitation by exploring different types of exergame and recruiting a more diverse population. We encourage studies to manipulate environmental factors and investigating how asymmetric display mode can affect collaboration. Finally, long-term studies will be valuable to reveal whether the positive effect we observe can lead into a sustained family engagement. That's all for my presentation. For more details, please check out our paper and feel free to reach out to us through email. Thank you very much.